Arkansas Row Crops Radio, providing up-to-date information and timely recommendations on row crop production in Arkansas.
Welcome to the Weeds Are Wild podcast series as a part of the University of Arkansas Row Crops Radio. My name is Jason Norseworthy, and I'm a weed scientist with the University of Arkansas System Division of Agriculture. Today, I'm excited to be joined by Dr. Aaron Hager, who's the Extension Weed Scientist with the University of Illinois. Aaron, hey, it's good to have you on today.
Jason, I really appreciate the invitation and an opportunity to visit with you this morning and your listeners. Looking forward to it.
Dr. Hager, we've had some conversations, I know, back this past spring about metribuzin, and I want to kind of keep that as the focal point, or at least part of the podcast today. And I know that you've been really excited about some of the research that you've recently conducted with metribuzin, and we both know that that's a very, very old herbicide, but I think it provides tremendous value for the management of pigweed species. Of course, in my geography, that's Palmer amaranth. In your geography, that's water hemp. So can you tell us a little bit about what you've been seeing in your work with metribuzin?
I'll be happy to. And really the idea of this came around as we look at the profile of resistance that we have in our water hemp species here in the Midwest. We see resistance now to herbicides that span 7 different sites of action. And several of these sites of action also include those types of products that we use in a pre-emergence application timing or a layered residual in with a foliar applied treatment. But so far, and I guess if there's a good story about our resistance issues that we see in water hemp here in the Midwest, is the fact that most of the triazine resistance that we see here is actually not target site based. And by target site based, what I mean is that there's a very specific change in the target site of the herbicide that does not allow for the herbicides to effectively bind and control the plant. So we have non-target site resistance, which in many cases is more of a metabolism based, or in other words, these plants are able to rapidly break down the herbicide before it causes any sort of damage that's sufficient to lead to death. Well, so what does that have to do with metribuzin? Well, when we see target site-based resistance, we see resistance to both the symmetrical triazine herbicides, which most commonly would be atrazine, for example, and the asymmetrical, which would be products like metribuzin. However, because most of our triazine resistance is metabolism-based, we lose the effectiveness of the symmetrical triazines, but the asymmetrical triazine, that would be metribuzin, still works. And so one of the groups of herbicides that we do see resistance to is our PPO inhibiting herbicides. They have things like the flumioxazins, the sulfentrazones, fomecifins, aceflorphins, etc. And how the resistance to soil-applied herbicides is manifest is essentially the length of residual control gets less and less. And so on a sensitive population, for example, we may expect 5 to 6 weeks of good residual control, but in a resistance scenario, maybe that is now 3 weeks of control, maybe that's 2 weeks of control. And so we eventually ask ourselves the question, where would metribuzin fit into this? Knowing that we still have fairly widespread sensitivity to metribuzin in our amaranthus populations, but yet widespread resistance to our PPO inhibitors. And that's really what spawned the work that we've been doing now for about the last 3 seasons here at the University of Illinois, taking a new look, as you mentioned, at an old herbicide.
Yeah, so I know for Palmer amaranth, we've done a good bit of work looking at mixing metribuzin with some other herbicides, or even looking at some of these premixes. And, when I talk about premixes, we have things like Trivence, Authority MTZ, Intimidator is a generic that's used here in the Mid-South. And a lot of these products, these metribuzin mixtures, it's what I would consider less than an effective rate of metribuzin. We're generally talking 1/4 pound of active ingredient, maybe a little bit less. And I think historically, for us, the reason for that has been the fear of injury to the crop. But What we found in our work is that when we run, for instance, on a silt loam soil, a half a pound, 3/8 to a half a pound of metribuzin in combination with something, for instance, like a metolachlor, which would be a boundary type product, or maybe even a Zidua, and we start with that at planting, that has been one of our more effective herbicide treatments. And as you mentioned, we've been looking at that on some of these populations that appear to have metabolic resistance, as well as some maybe target site resistance to PPOs, as well as metabolic resistance to PPOs and metabolic resistance to some other classes of chemistry. And with that, by far, it has been one of our better treatments. So tell me what combinations you've been looking at, or what kind of are your use rates that you're recommending in your area?
Yeah, very, very good. Historically, metribuzin was, back in the 70s, early parts of the 80s, actually widely used here in Illinois. But introductions of different classes of chemistry, new products came into the marketplace and essentially displaced, many of the acres that metribuzin once was applied to. And so, as we look at our demographics of many of our farming community now and many of the custom applicators we have in Illinois, not a lot of them necessarily were familiar with metribuzin or really could remember how to use it or at what rate that it should be used, since we have, soils in Illinois that range anywhere from maybe 0.5% organic matter up to 5 to 6% organic matter. And so the approach we took was we just selected a commercial metribuzin containing product. I believe it was Tricor, a 75DF, very similar to the old Syncor type products of years past. And we said, well, let's just not guess. And so for the soil that we had, we could go up to actually a full pound of Tricor, or 16 ounces of product. And what we ended up doing is we put 16 rates of Tricor in this trial. We started at 1 ounce and went to 1 ounce increments up to 16 ounces. And essentially what we found over about 2 or 3 growing seasons is that once we hit about that 10 ounces of Tricor, we really did not see a statistically significant improvement in water hemp control. All the way from 10 to 16, it was about the same level of control. So that really gave us the basis of trying to get a better handle, again, re-understand, if you would, the rate structure of metribuzin for some of our heavier textured black prairie soils here in Illinois. But you touched on a very important topic. We feel that many of the product premixes that contain metribuzin seems to be built around the other active ingredients. And so what our next step in this evaluation process will be is, now that we have a very much better understanding of the rate structure that we need on our soils, now we'll begin to look at what partners can we apply with the metribuzin. So in other words, if we were to build a new premix concept, our idea really is to build it around the metribuzin. Obviously, metribuzin is not full spectrum product. It's going to need help on other species, and then begin to look at other active ingredients that would complement that spectrum. Again, targeting and keeping our focus on our problematic species, again, for us, which would be the water hemp that has multiple resistances.
Yeah, so as you indicated, I mean, I like the idea of the focus being on metribuzin rather than on the additive within the premix. And of course, the concern with that becomes for a grower is, well, at least for the soil that I'm on, do I actually have tolerance? And we did some work this year where we went to a clay soil and we went up to 20 ounces of Tricor. And at 20 ounces where we had a tolerant variety, I think we had slightly less than 15% damage or 15% injury to that. So I think really the key is matching your tolerant varieties with the metribuzin rate that's going to be effective on your soil that you're actually applying it to. And with that, I know my program, we've actually spent a good bit of time here, probably over the last 10 to 12 years, screening germplasm across the U.S. For companies, as well as our official variety testing program each year. I evaluate the sensitivity of those varieties to metribuzin, and we place that information online and available to the Mid-South growers. And of course, that for us is going to be mainly a mid to late 4, maybe some early 5 soybeans. And what we've seen, Dr. Hager, over the last, I'm going to say 10 years is that there has been a tremendous, I think, interest in metribuzin from a breeding standpoint. And the reason I say that is because when I go back 12 years ago now, we had a considerable number of varieties that was coming through this trial that had sensitivity to metribuzin. And when I say sensitivity, at times we would even kill some of these in our screening. And so it wasn't, I'd say we didn't have commercial tolerance to this. But what I have noticed in recent years, the number of sensitive varieties has diminished greatly. And I think that's a result of the fact, again, the industry understanding the value and the need for metribuzin use in soybean.
No, really a great point, and this is a part of the story that we give every time that we talk about, the work that we're doing with the metribuzin. Certainly are the cautions. There still are cautions with using metribuzin. As you indicated, there are still sensitive varieties. We really don't know in Midwestern varieties how frequent these are. And the best recommendation that we can give is simply to, ask your seed supplier if they still screen these varieties. We, for soils here, we still have to take into consideration, the soil, the pH, the organic matter content. We certainly want to try to avoid metribuzin on fields that have high pH levels just because of increased availability and potential for injury. And something, I guess, that perhaps could be a little bit more common for us here in the Midwest would be the impact that atrazine carryover has on metribuzin injury. And as we think back to when metribuzin was more widely used in Illinois, if we think about where did we used to see much of the injury when we saw metribuzin injury, and in many cases, and by this I'm talking here now, 35, 45 years ago, it would be on areas where there was an obvious spray overlap. And maybe the rate back then was 8 ounces of Syncor. Well, in an overlap, now you're talking 16. Well, it doesn't take a big stretch of the imagination to think that if we were overlapping our metribuzin in soybean years, that perhaps we were overlapping our atrazine rates in the previous corn year. And so 40 years ago, if we were putting on 2.5 to 3 pounds of atrazine, now all of a sudden in the overlaps, we're 5 to 6 pounds. Now we overlapped the metribuzin in our soybean year, and that explained a lot of the injury that we used to see. Well, what's different between then and now? Well, certainly the rates of atrazine that we use are much lower. We're actually restricted on the total number of atrazine pounds that can be applied per acre per year. We also have modern application equipment, and overlaps are very rare these days as compared with when we were using pickup truck sprayers, back 40 years ago. And the other thing that we have happening in soils here in the Midwest, and in full disclosure, I really don't have any idea what the frequency of this is. But we have a phenomenon going on of accelerated atrazine degradation. Microbial populations have shifted. They're now using the atrazine readily as an energy source. And there was some published data from a journal article, I forget, maybe 2 or 3 years ago, looking at the degradation rates of atrazine in soils that have a history of atrazine use, comparing with those soils that did not have a history of use. And for example, for a soil from Iowa that had no history of atrazine use, the half-life there was about 47, 48 days. So it took 48 days for half of that applied atrazine to dissipate. In contrast, another soil from Iowa that did have a history of atrazine use, half-life there was less than 2 days. And so I think in many times the contribution of atrazine carryover toward the metribuzin injury in the soybean year may be quite a bit less than what it used to be, 35 to 40 years ago.
Exactly. I would agree with you totally on that. Of course, we have not historically been as big of we're not an ice state, so we do grow corn down here, but obviously not to the extent that you guys do there. But one thing also that we've seen in corn that I think may have some play back into with the use of metribuzin is, we talk about in corn the synergy that we get associated with atrazine plus HPPD herbicides. And, I've actually, one thing that gets me excited here around metribuzin is that I've taken a look at it in the LLGT 27 soybean, and we've looked at Elite 27 plus metribuzin from a pre-emergent standpoint, and we get a tremendous amount of synergy when we mix those two, or I say synergy, we get much more improvement in our weed control when we mix those two herbicides together. It's just extremely impressive the length of residual and the high level of residual that we get there. And also, not only the Elite 27 or the isoxaflutol product, but we've also done some work on the Elite 27 trait where we've had success mixing mesotrione plus metribuzin. So products like Callisto, products like Motif, which would be a UPL product, we've mixed those with Tricor, and we've seen a tremendously long, effective program out there in terms of controlling Palmer amaranth. Now, again, today, mesotrione products are not labeled in the LLGT 27 soybeans, or my understanding is we're probably looking at here in the near future some Enlist Elite 27 type soybeans going to be out there. But today, there's a lot of interest in actually taking the HPPD chemistry and mixing it with metribuzin from a weed control standpoint. Have you looked at any of that, or what are your thoughts on that?
Oh, I agree. I think there's a lot of opportunity there to include metribuzin with some of the HPPD products that are labeled in these soybean varieties. Not to try to downplay anything, but one of the other areas that we're going to begin taking a look at, actually, we've got the plots now established, but we see a phenomenon occurring here in Illinois, and I suspect many other states as well, where farmers are in many cases now planting most of their soybean crop before they plant their corn crop. We actually started a new experiment this year looking at weed management and what we call very early planted soybean. And for us, we planted those trials on April 6th this year. So that, I guess, begs the question from a use standpoint of mesotrione, which we use quite extensively in Illinois corn. If we get into some perhaps dry conditions where maybe we do see some carryover of mesotrione, is that a concern if we are also going to be recommending metribuzin on a very early planted soybean? Is that synergy going to be there to where we may see more enhanced injury? So again, kind of an opposite of effect of looking at the concept of metribuzin with HPPD for weed control in certain soybean varieties, but certainly something I think we need to be aware of if there is any potential there for enhanced injury from a mesotrione carryover perspective.
No, absolutely. I mean, that's you are correct, and it's funny you mentioned this because I remember that me and you had a conversation. I think it was around April the 10th this year, and you made the comment to me that you had already planted a soybean weed control trial and sprayed your treatments, and I was laughing, telling you that I don't know how far I'm 500, 600 miles south of you, and yet to put a weed control trial out. But one thing is certain for us, Dr. Hager, is that I know our growers are definitely trying to push that early planted window more so than what we did 10, 15, 20 years ago. And, with the seed treatments that we have in soybean, the seed treatment that we have in a lot of these crops these days, it's really given us the opportunity to get out there early, and that seed's able to lie there in the soil for weeks on weeks and us still be able to ensure that we get a good stand. So with that, the behavior of those herbicides and the interactions you get with those herbicides are much, much different than for us when we're out there planting mid-May, mid-June under warmer conditions.
Yeah, it gets off a little bit, Dr. Norsworthy, on the topic specifically of metribuzin, but it's going to be a good extension effort here in the next couple of years to maybe go back and revisit with farmers, custom applicators, some of the characteristics of soils that could either contribute to or speed up herbicide degradation in these soils from a carryover standpoint, if we are going to continue to push, the envelope, so to speak, in terms of early planted soybean.
Exactly. So, Dr. Hager, I know that you do work on other herbicides outside of metribuzin, and I know you've got a large program there in Illinois, as well as the fact that you work closely with your colleague, Dr. Pat Tranel. And is there anything you've seen in your research trials this year, or that you've seen in working with Dr. Pat Tranel, that just gets you excited and as we move into the future?
Oh, it's funny. Yeah, I guess getting excited about a molecular weed scientist is kind of a parody, but Dr. Tranel is a molecular weed scientist here at the University of Illinois. He's been here well over 20 years, and just fascinating individual to collaborate with. And we've done a lot of projects together down through the years. I'm the field scientist. He's the molecular lab scientist. But one thing that he's working on now that I really am quite interested in tracking what he's finding. He's trying to understand what governs a male water hemp plant or a female water hemp plant. So in other words, which genes control maleness in a dioecious species like our water hemp. Now, this could have applications also for your problematic dioecious species in Arkansas, of course, which is Palmer amaranth. But he's trying to identify what regions of the genome actually contribute to the sex determination in these amaranthus species. And they've actually got it down now to a fairly small region on a chromosome that they believe, based on their research, this is the region that contains the genes that determines whether a plant is going to be a male plant or a female plant. Their work continues to actually now try to identify the specific gene or genes. And once those are actually identified, I believe the next step in the project would be to employ some kind of gene editing technology. And can you actually release now pollen or seeds that are basically either male sterile or male only, and actually over time cause a population to decline? And it in many cases sounds like kind of a weird science project, but in reality, I believe there was a recent release of mosquitoes taking a similar approach and trying to edit out the genes responsible for sex determination in mosquitoes, and basically then there would be no male mosquitoes to breed with the females for future generations. So that's pretty interesting work for for somebody who started looking at water hemp as a problem weed about 26 years ago.
That is a very interesting concept. And I think what that also just goes to show is, at the end of the day, I'm a firm believer that chemistry is the foundation of what we do. For the most part, herbicides are going to be the foundation of the strategies that we approach. But in light of all of this resistance that we have today, it's going to take some extremely novel approaches, as well as some bright minds, I think, to come up with the solutions that are necessary to address these resistance issues that we've got in these weeds like Palmer amaranth and water hemp. And I'm really, really excited to hear, as you said, the work that you described from Dr. Pat Tranel. So
yeah, I agree with you completely on that. And as we move into what we're calling this new era, if you would, of resistance that actually is not necessarily target site based, but metabolic, as we talked earlier. I'm not ashamed to admit there's probably more things that we don't understand than what we do understand. And it really makes it a bit tenuous, perilous, if you would, to try to make herbicide-only recommendations to manage these weed populations that have actually shown no limitations so far in their ability to overcome a chemical-only strategy. So, technologies, integrating new technologies, whether that be gene editing, whether that be sterile pollen, whether that be bringing back a hoe or a weed hook, to ensure that by the end of the season that there's no seeds produced, that we know will give us a victory. Opening up a new jug is just kicking the can down the road.
I agree with you totally. And, I think at times some of the strategies that we may have in place in terms of rotating modes of action, which again, I'm a big fan of rotating herbicide chemistry, herbicide modes of action. And I think that's a very effective tool in terms of mitigating target site resistance. I'm not certain today that some of those same strategies really apply to the metabolic resistance that we're encountering today. And really, I'm seeing a major shift, I think, from a research standpoint, from just focusing on target site resistance more so to metabolic, because I really think that's going to be the game changer as we move forward.
Yeah, I agree completely there, Dr. Norris. Where, as a matter of fact, we used to do almost exclusively research on target site-based resistance, but in reality, our program, Dr. Trownell's program, Dr. Rieger's program here at Illinois, it's been many, many years since the focus was on target site-based resistance, since about 2009, 2010, when we first stumbled upon HPPD resistance. Almost exclusive focus now on trying to learn more and better understand, what is leading up to this metabolic resistance, and gives us a better understanding of why we can actually find populations of weeds that are resistant to herbicides that they previously were never exposed to.
Okay, Dr. Hager, I'm going to wrap up this episode of the Weeds Are Wild podcast series on the Arkansas Row Crops Radio. I hope our listeners have found this to be informative, and I hope our listeners look forward to the next time that we're able to join you again on the Arkansas Row Crops Radio.
Again, thanks for joining us for this episode of the Weeds Are Wild podcast series on the Arkansas Row Crops Radio.
Arkansas Row Crops Radio is a production of the University of Arkansas System Division of Agriculture. For more information, please contact your local county extension agent or visit uaex.uada.edu.